All right, I think we'll get started. Good morning again. Welcome to GrrCon 2018. Excited to be here. As always, how many people saw my talk last year here? I see maybe about 15% or something. Quite a few. This talk kind of follows that, basically. It's sort of a continuation of sort of a similar theme, going deeper in kind of ProdSec. Last year I talked about embedded security and some of the easy wins out there using Showed-in and finding open cameras and kind of a lot of the easy stuff that's out there kind of to hack basically in the sort of IoT embedded space. And this kind of goes a little bit further as far as now how do we actually go and find Ada and kind of drill deeper into products, because it's a thing that still a lot of businesses aren't fully 100% up to speed on. They're doing pretty good with ITsec and pen testing for the corporate network and stuff, but they're not, they don't necessarily have the same level of understanding on the AppSec, ProdSec side of things. So that's what this talk is really about. So everything good on the video, audio? Everything okay? All right. Great. Well, my name is GrrDemont, and I've been in this scene a long time, 18 years. I started with the NSA in 2000 and worked in various government, academic, startup businesses, did a PhD from Michigan State. My former advisor is right here up front. Wave. Hello, Dr. Anybody. And now own VDA Labs, and we have a lot of fun doing pen testing, code auditing, incident response, all kinds of cool stuff, training, whatever you guys need done. If there's somebody, we have a booth here. If you want to go talk to Michelle, or Greg's right there. Say hi, Greg. He's one of our engineers. I know James. Where's Nick? Is he in here? Where's Nick? I don't see Nick. But anyway, if you want to talk to some of our folks about what we do, feel free to do that. I won't belabor the point now. But one of the things I like to start off by talking about is when you talk to security, the main thing you need to know is that we're here to help, right? And that's one of the things when you talk about how we want to get this ProdSec done, right? Your business is making a new product, you're making a new whatever it is, and a lot of times developers have a little anxiety about that. If you're going to get a pen test done on their product, they have some fear associated with that, thinking, well, maybe I'm going to get thrown under the bus, and maybe, it's going to be a really scary event when they find, vulnerabilities in my product, and like, what's that process going to be like? And that process is going to be good. If you work with a good partner, they're going to find stuff, and they're going to help you get it fixed, and the ultimate goal is to make the product better. So that's the first thing I like to start off by letting people know, is that there shouldn't be as much anxiety around pen testing and kind of, code audits and things as sometimes I think there is. We're here to help, basically. We're part of, what's making the thing better. And like I said, what motivated this talk was that we see a lot of, corporates and things. They know about external, internal phishing, physical, wireless apps and things, but they don't know quite as much about ProdSec, product security and assessments that are associated with that. So that's what I want to talk about, is kind of cover what's that all really about. So a product pen test is a little bit different than a corporate pen test. Instead of testing the network and the domain and, that type of stuff, it's more, starting with the development of the project. Do the developers have proper training? Do they know about the SDLC? What kind of code testing are you doing? Are you doing it on the components, static, dynamic analysis manual, all this sort of stuff? How to triage, how to deal with reports when they come in from the field, kind of having somebody on sort of incident response. But product incident response is very different than corporate incident response, right? It's more like, how do we respond when somebody reports a vulnerability in our product to us? What's the process of dealing with that, rather than, we've gotten ransomware on an endpoint or something. They both, a lot of times the same term, IR, gets used, but it's a very different process when you talk about code projects. So that's kind of what we're talking about. In the sort of the high level process, it looks something like this, where you've got an investigation of the product. You've got some automated analysis on the code of the binary. You've got some automated and manual analysis on the attack surface. There's some dynamic analysis, some deeper manual hacking. That's where we really find our best bugs, is when we drill in personally, manually, with kind of the experienced pen tester hacker types. That's where the tools kind of are a great way to begin, but they only get you so far. And then showing impact with a proof of concept vulnerability exploit to help the owners of the project or the decision makers really get the impact. And we'll look at that and talk about that. So the first thing you need to do when you start security of any kind is make sure that you've got the right buy-in from everybody. It works best if from the top down you've got executive leadership and all that saying, yeah, we're going to support this. We're going to make sure you have budget for training and pen testing, all this good stuff. That's where it really works best. And there's a whole bunch of different steps associated with that. We're not going to talk about all of that. We'll kind of gloss through sort of the beginning details, like I said, in the interest of time. We'll kind of keep moving. The other thing I like to point out is that ProdSec is just a very small piece of the overall security picture for a large company, right? If you think about what a CISO or a chief security officer or somebody in whatever their title is, VP of security, or it doesn't matter, or just owner of a small business, right? Because businesses start from one person to, hundreds of thousands of people. There could be lots of different things on their plate, right? They might have concerns like governance and risk. They might have strategic goals like insider threat, which is now being called UBA. There could be different tactical efforts in terms of training or testing, engineering. So ProdSec is the actual hiring of a pen test to test the security of your product is really just one small piece of that. And it's kind of a specialized piece of it, right? And because of that, a lot of companies, like we go out and work with different companies. One that comes to mind is Johnson Controls. They now have a chief product security officer, which is separate from the chief information security officer. And I think for larger companies, that makes a lot of sense because in many cases, your CISO may or may not even have sort of a technical IT background, but they probably definitely don't have a developer background. There's a chance maybe at some company they do, but mostly not. So having somebody that has a little bit more of an understanding of development and code and stuff like that, I think makes a lot of sense for larger companies. Again, for smaller companies, maybe if you're a 4-person development firm, maybe that just means one of your devs spends 10% of his time doing security, right? You fit this in however you can based on your budget and your size and your structure. So when you look for a partner, kind of a small tiger team, a pen test partner that's sort of really this is what they do, that's kind of the partner you're looking for. And I've got a bunch of slides, and sorry if I kind of skip through them real quick, but that's one of the things I wanted to point out there. The other thing you're trying to do is obviously raise the knowledge of security across your whole organization. That's, again, part of why you would get a test done. And so whatever you learn from that test, if you find vulnerabilities, you should probably, hopefully you will, and then you kind of put that back into the process of trying to figure out how did that happen, what could we do to get rid of that whole class of bugs, and so kind of raising the knowledge of that from the owner of the business down to the newest tester, basically. That's really that's the goal of any of these continuous improvement models. Microsoft has one called the SDLC, the Secure Development Lifecycle. Synopsys has one called BSIM. OWASP has SAM. So there's all these different models, and basically at the heart, I'm not going to go through all those models, at the heart of them, you'll find that each model has something like governance, the construction of software, the verification and testing of software, and how do you operate the software and deal with it when it's fielded. They all kind of work with different practices and domains within that, and there's a lot to each one of those. You can get a whole assessment done just based on that to figure out how mature your organization is, using one of those and things. But we'll kind of gloss over that for now. And we'll start talking about things like why do mistakes happen in code in the first place before we start this. There could be a lot of reasons, right? It could be that devs aren't properly trained, or there's confusing APIs, or there's some disconnect between partners, like maybe one company developed this piece and another company developed another piece. We see that a lot where the handoff happens. It's not perfectly seamless, like, oh, I thought you were going to test the API. Oh, no, we didn't do that. We just made the hardware piece. I thought you were going to secure the API, that kind of thing. There's a lot of reasons why mistakes could creep in. And, there's plenty of others, lack of proper algorithms, how data is stored, maybe not encrypted, maybe not using the latest systems. We see that quite a bit where, the machine that's going to do some high-tech thing is really outdated. We see that in medicine a lot. Like when I had my LASIK done, he's like, put your head in this super advanced machine that runs Windows XP. As I'm looking at it, I'm like, is that running Windows XP? Like this is going to do my surgery, this is not making me feel good because it doesn't have depth, it doesn't have ASLR, it doesn't have code signing, it doesn't have sandboxing, it doesn't have all these things that we know about in security for a lot of years. So maybe it has malware on it and it's going to crash right when it starts to do one of my eyes or something, right? So that type of thing is certainly something that we think about. The other thing is that with software and products, mostly they're assembled nowadays. If you're going to go out and make a new IoT camera or whatever it is, you're probably not going to write all that code from scratch. It's going to be, we'll take this graphics library, we'll take this library, we'll take this library, and somebody's going to sort of string it all together. And in an IoT, it doesn't get strung together very well a lot of times. It's sort of like a horrible collection of bash scripts, Perl, Python, and C or something that kind of strings together all these libraries, leaving them fairly vulnerable. So And that's the other thing is how are you going to keep all those imported libraries up to date? 'Cause that's a big thing, right? You're leveraging all these other, if you've got a really old version of Linux, you're sort of vulnerable right out of the gate, basically. And that's something that we want to avoid and something that, as you think about the design and the security up front for your product, you can avoid a lot of the cost of dealing with that down the road, basically. There'll be less incident response, less retooling, less recoding if you kind of think about that up front. So, let's see. One of the other things we see, maybe you don't have a secure update feature. That's really big right now in OTA and over-the-air update. It's really big for cars. It's really big for everything. Like, when's the last time you went and updated your cable modem or your home Wi-Fi router or something? Most of them don't update themselves. You have to go and download the firmware manually and apply it, and like your grandmother's not going to do that. I don't even hardly remember to do that, right? Actually, I do because I'm like kind of paranoid about that. But most people don't remember to do that type of stuff. So doing that is good. Also, when it comes to a lot of the apps and APIs and logins, it's so easy to lose your password. Not of any fault of your own. Maybe you have a bad password, but maybe your user and password involved in some kind of breach that you don't even know about. So having multi-factor authentication is huge. That's one of the hugest things we talk about. So that's another design thing that would be really good to get into your product right from the get-go. Have a dual-factor authentication method that at least people can opt into if it's not required. That would be really good. So then the other thing is that's very similar to IT security, which we see in product security, is getting the basics right. Are you doing the very, kind of the 20% of the effort gets you 80% there sort of scenario? That sort of always holds true in every domain, right? And it's true in security as well. So, for example, does this, HVAC controller or whatever the IoT thing, embedded product, whatever it is, does it need to be on the same network as your domain controller? Probably not. Maybe it could be segmented. Maybe it could be, there's a lot of sort of basics. Maybe we could monitor it. Maybe we could check to see, are there ways that we could keep an eye on this thing in various ways? And there always are pretty simple ways to do kind of the basic strong passwords, all that good stuff, keeping it updated. Still good stuff. Maybe go and check and see if you find your product on Shodan. Shodan.io is sort of the Google for stuff on the internet, right? It's like you don't have to scan things anymore manually. You can just go to Shodan and look for, show me everything on port 774, which is maybe your product, for example. And it's like, oh, wow, there's a lot of them on the internet. That's weird. We didn't expect that. We thought most of our customers would put them behind a VPN or isolate them in a private network, but it turns out they're not. Why not? Like, maybe there's something confusing about our deployment guide that maybe we don't have a deployment guide. That's the confusing part. That's pretty common too, right? So that type of thing is all the sort of basic stuff, right? Let's see. Yeah, I talked about that. Least restricting by IP, least privilege, all that kind of stuff is sort of the basics of IT sec that we've known about for years. All that stuff still applies to everything that's out there, products in particular. So let's see. Oh yeah, in physical security too, I see this one quite a bit where if you're just walking through an airport and you realize, oh look, there's a thermostat, I could just plug into that. You'll notice there's an Ethernet connection below it and you're on their backnet, which is a really insecure ICS, industrial control system network. So that type of stuff, again, it's sort of the basics, like maybe they should just have a locked box over that, even if it's just plastic or something. It's sort of not perfect, but it would keep the casual person from just walking up and plugging in some device and leaving it or something. So that type of stuff, to me, always falls into the basics. The other thing you want to think about is how do we, once our product is in the field, and people are going to be looking at it, reverse engineering it, trying to hack it, trying to find vulnerabilities. Who's going to do that? All kinds of people, right? Could be home users, could be malware authors, could be nation states. There's a lot of people that are going to be vested in attacking your product. Even things that you wouldn't necessarily think. Like I recently saw these IoT padlocks. I don't know if you guys have seen these. You put your thumbprint on a padlock, and from your mobile, you could unlock it if it's your gym locker or something, or you could see who's tried to touch it, or if somebody tried to unlock it or whatever. Very simple IoT device, and you think, why would anybody want to hack that? Or, well, first of all, it's got your thumbprint in it. The other thing is maybe it's attached in some way to your local network. They could use it as a staging point. So there's always more motivation behind getting into stuff and getting onto things than you might expect, even if it seems like sort of it's just my gym locker, sort of thing, right? And so things you might want to do to prevent that are maybe encoding the binaries in some way, not shipping debug symbols with your built compiled binaries, because it makes it so much easier for us as hackers to reverse engineer if you ship your PDBs, which is the Windows debug symbols, with your product. Also, if it's written in .NET, which a lot of stuff is nowadays, if you don't explicitly obfuscate it, it's also super easy to turn right back into code with some decompiling tools. So and think about how are we going to protect our intellectual property and prevent people from finding bugs quickly. Because even if you know that those aren't perfect security measures, if you obfuscate your binaries and hide your debug symbols and stuff, it's not going to stop people from finding vulnerabilities. But if it slowed them down even 6 months to a year, maybe by then your next version's out already, right? It's more of a time thing than anything else, than a true security measure. So that's really important to keep in mind. The other thing is, excuse me, have a security@yourcompany.com. We've been saying this for 20 years, I think, in the security field, that if I find a vulnerability in, whatever the product may be, I should be able to email security@company.com and get a response within at least a day or two, a couple days maybe at the latest, right? And if that doesn't happen, it's like, why didn't that happen? Why don't they have that set up? Well, this happened to us recently. We found some vulnerabilities in IoT products in some cameras, which turned out to be a Chinese company, and we emailed security@vivotech.com, and they actually responded basically in Chinese, like, we don't speak English, we'll get back to you in a week or two when we find somebody that does. And that was fine. I mean, at least it was a response, right? And they eventually got somebody that responded back in English, and we had reported like 3 bugs, and they're like, so the one we think is a bug, but we've handled it in a new version, so we don't need to fix it in the deployed stuff. And the other one's not a bug, it's just a stack buffer overflow, it doesn't hurt anything, so that won't be a problem. Which was horrifying, right? Because they were all exploitable vulnerabilities, and we were trying to explain it to them, and they really didn't get it, but at least they tried. Where recently with Epson printers, we found a number of vulnerabilities in their stuff, and we could not find anyone to get a hold of after like a couple months of trying. And so this blog on our website related to Epson vulnerabilities, those are like O-Day vulnerabilities, because we could not find anybody to get a hold of. So sorry, if there's somebody from Epson here, you should probably go read that blog, because we still haven't heard from anyone. We've been emailing people for like weeks and weeks and weeks, so it is what it is. And that's the whole thing. Like, why isn't there a secure@epson.com? I don't know. There's not. There's not anybody on Twitter or LinkedIn or anywhere else that responds to security events either. So that's not good. And that's kind of the whole, part of kind of how do you respond to researchers when they find stuff things. So, okay. So that's all the background material that I wanted to cover. I tried to do that as quickly as I could. I did okay on it. It took me 15 minutes. Now into the sort of the 6 steps of conducting an actual ProdSec. What's the first step? The first step is basically sitting down with your customer and walking through the process of figuring out, what is this thing? Why do you want it tested? How big is it? What's it like? What's it do? What kind of assessment do you want? Really kind of it's sort of like consulting 101, but it's really important in every consulting endeavor, especially in a security assessment. And so one of the things we always have to explain a little bit is, do you want a white box, gray, or black box assessment done? Because most of our customers, I would say at least half, don't really know the difference of why you might want one versus another, and kind of what the differences are. So briefly, the difference is, if you want a black box assessment done, that would be like, what can somebody with zero knowledge do to hack my, whatever, Ford or whatever it is you're interested. Like, we're not going to give them any help at all. And that can be an interesting test to kind of see what could somebody kind of from a zero knowledge standpoint figure out. Sometimes companies want to know that, and that's a valid thing to do. The downside to that is that the testers spend the vast majority of the assessment trying to figure out the basics. How do we get debug access? How do we get the binaries off the machine so that we can run static analysis? How do we, kind of begin to get sort of the basic level of access that we need to really do our job well? And so a large portion of the test is essentially wasted on that. Which, if that's what you're interested in knowing is how long would it take them to figure that out, then it's a totally valid thing to do. On the other hand, gray is moving more toward white box, which white box would be like, they provide full source code and full access and a debug console and backend and login credentials and everything you would need to do your job from a security analysis standpoint. Gray box is somewhere in between. Like, maybe we don't give source code, but we give most of everything else. We give consoles and binaries and things like, maybe even debug binaries, things like that. Which, by the way, if they give us debug binaries, in many cases, especially, like I said, if it's .NET, they've given us source, which they mostly don't know that until they get the report, and they're like, oh, wow, how did you analyze our source code? It's like, well, you gave us debug binaries, and it's .NET. So that's how we did source code analysis. And then, yeah, white box. So that's kind of the entry level. And if you look at some of these maturity models, like the BSIM SDL thing I talked about at the beginning, knowing that you might want to give your pen testers more data to help them get started faster, that's a sign of maturity in your organization. So, for what that's worth, that's something to think about. So once you've kind of got the basics established around the assessment, the first step would basically be learning something about the domain. So if this is an automobile versus an ATM versus, a military application, something like that, it's very different. The way you work with those customers, the things that they're interested in, it varies a lot. For example, in the auto, medical, HVAC, safety is big. They're not so interested in like, oh, somebody could hack your car and steal your Bluetooth data or something. It's more like, is there a customer at risk of getting hurt or injured, killed? That's really a big concern for them. Where if you're doing, say, an ATM assessment, it's like, are they going to be able to jackpot our ATM and steal all the money out of it? It's financial. And with defense, it may be more like, cool, you found an Odo. How do we weaponize it and use it as a cyber weapon? Like the military is very interested in that. So you need to like sort of learn to speak their language so that you understand what your customer cares about, basically. Okay, so and the other thing is, if they have any other sort of design docs or that type of stuff in this initial investigation phase, that's the time to look for it. In particular, as you just do some basic internet research and things like that, don't underestimate that. A lot of times we found, you just Google what's the default password for a VivoTech camera. Oh, it's admin. Oh, cool. Like so, game over. I'm in. So sometimes just very basic research is enough to give you a head start. Sometimes it's not. You may find out nothing, in your sort of early research. That's okay. You'll at least find, hopefully, something, a user manual, deployment guide, something that would give you some insight into how this product works, who uses it, what does it do, what kind of data is stored within it, that type of stuff. Public rants by prior developers that were fired, things. We found all kinds of interesting stuff when you just look for what's going on with the product. So other things, maybe lost credentials, that part of the LinkedIn breach, or who knows, right? You may have all kinds of interesting capability toward this product. The other thing, and it's typically not in scope for most product assessments, but if it is, you could basically phish the lead developer and steal the source code off his box if they didn't share that. Or like, there's lots of different ways to attack a product rather than just attacking the product directly, right? Hackers are very creative. And so as pen testers, the more scope they give us, the more creative we get to be too. So I'm not saying you definitely shouldn't do that without permission as part of an assessment, but if it's in scope, go for it, right? It could be a really interesting way to see if their staff is, vulnerable to that type of thing. It's a very valid sort of thing. And then, of course, any third-party connections, APIs, we see that a lot, where they might say, hey, we want you to assess the security of our padlock or our home security thing or our automobile or whatever. And the first thing I think is, what's it connected to? Is there some website I can go and just log into and that gives me access to your vehicle? Or some app? You see a lot of apps where you can unlock a car through their My Car app or whatever. Mercedes has one, I know. A lot of the cars, there was one in the Nissan Leaf a while ago. They had a vulnerability in their app where you could kind of find any car through their VIN number and stuff like that. So a lot of times this is easier than, let me dump the embedded firmware and reverse engineer it and look for a buffer overflow and a C binary or something. That's harder than oftentimes just maybe trying to like brute some login or something like that. So we always look for the sort of easy stuff first. Finally, once you've learned enough about the product, now it's time to figure out what are the tools for this job. Not what are the tools in general. We know about all the tools in general. We know there's Ada Pro and there's, Coverity, static analysis, and there's all these tools in the world for, conducting AppSec assessments, but what are the tools that are most helpful for this particular job? And that's where the prior research we just did helps us figure that out. And part of it is, what language is this? Because, knowing that it's, say, C, we might be looking more for the memory corruptions, where if it's more web, we're probably looking more for OS top 10 and stuff like that. So once we start to learn more about the product, what does it do, how is it built, what language is it written in, what kind of volumes are we looking for, that sort of helps inform what kind of tools we might be interested in using to perform our analysis. And the OS top 10 has changed throughout the years. 2017 is the most recent version of it, and there's lots of that, and I won't go through it all. But it's the kind of things you probably heard about, like SQL injection and cross-site scripting and all that kind of stuff. We see a lot of that. Command injection is a big one in the IoT space. We see a lot of command injection, where you can basically, in a username field, you can put in like semicolon and then run some arbitrary Unix command, that type of vulnerability. We see a lot of those. So now's the time to do basically our static analysis. And the reason we do that first, if we can, if we have code or binaries, that if we don't, then we go right to some, other, dynamic or manual or, burp suite or whatever. But if we have something that we can do static on, the reason you want to do that first before you get into the other sort of juicier manual testing and stuff is you get this broad look. That's kind of the big pro of static analysis across code, is that you get to sort of, I'll run this tool across your whole code base. And it's going to give me false positives. That's the downside. And it's not going to find every bug, but it gives me this nice, quick, relatively quick, broad look of the code base. And so that's the big thing there. And as a third-party auditor, like a pen testing company like us, what tools do we have access to? Well, in particular, we have access to lots of tools, both commercial and open source. But that's the kind of thing you're going to be looking for, trying to figure out what are the best tools for the job. And we'll talk about some of them. There's both commercial and open source. Commercial tends to be a little better in the static analysis space than open source. Like, it makes sense, right? And these companies have put a lot in making these tools. They can't give them away for free. So that kind of makes sense. And some of them, if you're a Gartner Magic Quadrant believer, this is both those. This is a Magic Quadrant and Gartner, and the top few are like VeriCode and Synopsys. They tend to sort of be at the top of the static analysis game. There's plenty of others as well, but those ones are ones that we've used for sort of the SAS, DAST, IS, MAST. These terms are new. They just changed those terms. Those buzzwords used to be a different buzzword like a few years ago, but now they've kind of changed the words they use. But it basically, can they do static, dynamic, other types of analysis? Most tools can't do it all, even though they sort of claimed it. Like, we have a suite that does it all. Yeah, I know. But only a few things in that suite are good, and to get the other things, I have to go to some other suite. Like, that's kind of the reality of almost all tools, basically. So before we get into the actual code analysis, there's SCA, which is kind of a growing trend of basically, looking at the ingredients of your food item and saying how many proteins, how many whatever. That's SCA, basically. It's sort of, what does your product use? For example, if you drop a Wi-Fi router and you use an old version of Linux, which means you've got 300 vulnerabilities or something, doesn't mean an attacker could necessarily exploit 300 things in your IoT. Oh, wow. But it does mean that you have some outdated components that need to be looked at. On the compiled code analysis, I'll show you a few different tools. This is VeriCode, so if you drop like a debug build of a binary in VeriCode, it'll give you some vulnerability, like, hey, here's a command injection or whatever, if it works good. And that's cool. Those reports are good. Coverity is interesting too, because it'll actually give you the vulnerability in a code section, but it's really hard to use kind of for a pen tester because you have to have code that builds. And that's easy for devs and a lot of times not as easy for third-party auditors, because sometimes even if they share code, it doesn't build because they didn't give us all the dependencies and things like that. But it's possible. We do use it. There's tools that integrate right inside of Visual Studio. There's open source tools, and this is kind of a key takeaway on the tool side is, hey, for every job, just go and look for the tools that are out there. Maybe somebody just put a new tool on GitHub. We found Brakeman a while ago when we were doing a Ruby job. Somebody just put out a cool tool to do some Ruby analysis, free open source. Cool, go find it. We look for that. And this is showing how to decompile .NET code with JetBrains decompiler. You may have to use down in the weeds sort of, assembly analysis tools like IDA Pro or Binary Ninja. Hopefully you don't have to do your static analysis there. That's the hardest part. So dynamic analysis is the third part, and the cool part about dynamic is there's less false positive, right? If I can touch an interface to your product and it crashes, that's a real bug. So there's not as many false positives, but you're only touching kind of the attack surface, right? And so what are some of the tools in this space? There's open source web scanning tools called Arachne. We've used that. There's also commercial tools. Like VeriCode, again, can do website scanning. Burp just added more capability to do some web app type scanning analysis. That's a look at one of their reports from Arachne. So you get some vulnerabilities. If it's more of a compiled app written in C and C++, it's maybe more like AFL or other tools that you might have to use. So I don't have a lot of time to explain what fuzzing is and all that, but there are some tools out there. There's a free one called AFL, the American Fuzzy Lab, which is quite good for analyzing local programs. If you got a binary that takes an input, it does some genetic analysis to create better inputs to find bugs. Microsoft actually has a fuzzing as a service tool that you can pay for, which they call the Microsoft Security Risk Detection, which is very similar. So they use Sage under the hood instead of AFL, but it actually has an AFL option on there. So a lot of options there. Now, once you've done all of your automated analysis of all those types, static, dynamic, all this stuff, this is the time where you really find the bugs now, the manual hacking. This is where we drill in, we find our best bugs manually by sending web requests back and forth manually and looking at the fields with Burp. If you haven't heard of Burp, you probably should. It's a good tool for that kind of manual inspection of web apps. We use it a lot for that. It could also be manually auditing C code or assembly or whatever the job requires, right? This is what we talked about. You have to kind of figure out what works for this job. The same tools don't work for every job. If it's a native C app, Burp doesn't do anything for you, even though Burp's a really cool tool. That's more for web apps. So you have to kind of know what your tools are. And then once you find some good vulnerabilities, basically this is kind of driving toward the end of the assessment. It's sort of like, how do we help the decision maker understand that this is really important? Because we kind of see this a lot where if you just say, hey, we found command injection or SQLI or whatever, and you just have a report that just says that bland, that's it. whoever is the decision maker is busy and they read a lot of stuff all day long and they're like SQLI, I don't know what SQLI. Like they kind of the impact of that is lost. Where if you show them that, hey, I can get a shell on your system, and from that shell we were able to do other things like get into your cameras, or if this was, let's say this was a student database, we dumped all your student social security numbers, or like the decision maker all of a sudden, like they get that. They're like, oh, that's really bad. That's the thing that's not supposed to happen. So having a proof of concept exploit to help communicate impact is really important. The last thing is just having a good report and helping them work through that and understand that, hey, no org is totally bad. Nobody's a 0. Nobody's a 10. Nobody's perfect. You're somewhere in between. You're a 6 on this product this year. How do we get you to a 7 or an 8 next year? And that's really the goal. And making sure that organizations aren't incentivized in weird ways. Like we've seen some credit unions that are like, hey, the board just told us we can never have a finding in our pen test report again. Thou shall not. And if that's mandated from on high, guess what'll happen next year? Whoever's in charge of hiring the pen tester will be like, who's the worst pen test company you've ever heard of? Like, they'll make sure that there's no findings in the report, right? Because that's what they're being told to do. You don't want to have that be the case. You want to make sure that your executives understand that you should be finding stuff in your network and in your code. And it's not about clean reports. It's more about how many critical bugs did you find this year and how many did you get fixed in a timely fashion. That's the metric that they should be driving toward and incentivizing their staff to work toward. And finally, when you give that report to them, working with the customer about, is this real or not? In most cases, especially in ITsec, when we've said, hey, we got to your system, we moved laterally, we got domain admin, we cracked your hashes. Most IT folks we worked with are like, oh, that's bad. We're like, we'll fix that. They're really interested in that. Where on the dev code AppSec side, sometimes we get answers more like, well, actually, that is not a problem, and I'll tell you why. Like they have this thing where they want to kind of argue with you about the findings, and it's a really weird scenario that we've had it happen a few times. And usually it's because they made a design decision at some point, like we can't use TLS because it's too much data, so we used UDP or whatever. And it's like, well, that's not secure, so we're just letting you know if you don't want to fix that, time is up. Okay, so anyway, I made it to the end, right to the last second. Thank you. This is my website, by email, Twitter. If you have any questions, I will kind of head to the hallway, and thank you so much for coming to the talk.